rational expressions, it's adding and subtracting fractions. What do you have to have in order to be able to add and subtract fractions? Common denominator. And more specifically, a least common. Right today. Common denominator. A least common denominator, we'll call that LCD. We'll abbreviate that as. The least common denominator is going to help us. We're dealing with polynomials here. When we're dealing with just numbers and adding, subtracting fractions, you could deal with not having the least common denominator and still be able to do it and just simplify it in. Since we're dealing with polynomials, you don't want to end up with extra polynomial stuff in there because that's a lot longer process to simplify with, because you got to do all this factoring, multiplying out and stuff like that. So getting the least common denominator to start with is a big deal, and that's going to be a big deal for adding, subtracting. It's also going to be a big deal for solving equations, which is the next thing that we'll do. So if we can get the common denominator or the least common denominator, it's going to help us with the equation stuff. So let's just start with some fraction adding. Let's start with something really easy, like 7 over 4x plus 3 over 4x. Well, do they have a common denominator? Yes. Do I have to do anything to them? No. What do I add? 7 plus 3 is 10 over 4x. And then all the time we've ever been dealing with fractions, the rules were once you got to the end, you had to check to see if you could do what? Simplify, reduce it. Okay, 10 and 4 are both divisible by 2, so we're going to simplify that to be 5 over 2x. Common denominator was already there. We didn't have to do anything. That's nice. That's great when that happens, but that's also Algebra 1. So we'll do another easy one just to help your confidence. Denominator is already the same. It's x plus 3. That must be a binomial this time, but we can do that work. We don't have to do anything to get a common denominator. So we're going to take and subtract what? 10 minus 17 is -7. And then the x plus 3 is what's on the bottom. We look to see if we could simplify. Notice, will x plus 3 factor? No, there's nothing we could do to factor that or get something that would divide with the -7. So we are finite on that one. So easy stuff, right? Let's take an easy one. 2x plus 2 over x plus 2 plus 2 over x plus 2. So yet another one that the denominator is already the same. So we just add the numerators, right? What parts of the numerators do we add together? 2 and 2, right? That like term. So that'd be 2x plus 4 over x plus 2. Well, is that it?
You can factor the top.
The top part will factor. Does that necessarily always mean that it's going to simplify? No, it's got to factor a certain way to simplify. So if I factor the top part, 2 is the common denominator. That'll leave us an x plus 2 in there. And x plus 2 over x plus 2. What happens to those? They cancel out, and our final answer is just 2 out of that. So happen to be some factoring that could help us. If you factor it and nothing cancels, then that's okay. That means that's the simplified version of that. And I would take the factored form or the unfactored form. But you've always got to look for those simplifying pieces. Won't always work. Sometimes it does. Okay. Let's do one more there. 4x over x minus 3 minus 12 over x minus 3. Again, denominator is already the same. So just do the math. 4x minus 12 x minus 3. The numerator can factor as a 4, the GCF. And then same thing, kind of things happening here. The x minus 3s are canceling. Write the wrong thing. Said it. Try to write it. The plain old 4 is what we got left. So we had 16x squared over 4x plus 5 x minus 2 minus 25 over 4x plus 5 x minus 2. Looks a little tougher here because you got more stuff in the denominator, right? But what do we know about it? It's still the same, right? We've got a 4x minus 5 times an x minus 2. The other denominator has a 4x minus 5 times an x minus 2. So the denominator is already common. It's the same. So we're going to do the math up top, right? 16x squared minus 25. And nothing changes about that denominator. And then I've got to look at it and say, okay, well, can I simplify this fraction at all? What do I know about 16x squared minus 25? It is a difference of squares that will factor as what? Minus 5 and 4x plus 5. Yeah, it doesn't matter what order you put those in. And then 4x plus 5, x minus 2. What do we know happens there? Yeah, the plus 5s, 4x plus 5s cancel each other out. And there we're left with one thing on the numerator, one thing in the denominator. That's going to be our answer. 4x minus 5 over x minus 2. A little bit of simplifying at the end. That won't always be there. We've got to, we do that a lot here in the notes just so you know to look for it. Okay. You won't always be able to simplify, but you've got to look for it every time, just like with regular fractions with numbers. Not always able to reduce them, but you've got to look to see if you can out of that. All right, now let's look at some that the denominators are not the same and see if we can make that happen. We'll start with this one. Let's say we had 3 over 7 plus, make that 5 over, we'll just do x. Something real easy to start with. We've got a 3 over 7 and a 5 over x. We got the denominators of 7 and x. So we need to find the least common denominator between those two. Was there anything in common between 7 and x?
No.
No. So there's nothing that's shared. So when we go to do the least common denominator, it's just going to be the product of those two, which is 7x. Then we've got to go back and fix those. Now, when we did fractions with numbers, way back, maybe it was a problem like this, 3 over 7 plus 5 over 4. It's the same idea. The common denominator for 7 and 4 was what? 28. What 28 is really 7 times 4, right? That's where we're getting that from. So what do we have to do to this fraction? It didn't hit the ground. What do we do to the first fraction to turn that bottom into a 28?
Multiply by 4.
Multiply it by 4. So we're multiplying the first fraction by 4. If I multiply the bottom by 4, what else do I have to do? Top has to be multiplied by 4. And this one we got to multiply by 7. So if we're doing it with variables, same idea, right? What do we have to multiply this first fraction by to turn that into a 7x? X. So whatever the bottom gets, the top gets. What do we multiply this one by? 7. Whatever the bottom gets, the top gets. So that's going to be 3x over 7x plus 35 over 7x. That's just going to be 3x plus 35 over 7x. And 3x, 35 don't have anything in common, so I can't factor that to simplify. So there we've got a common denominator, and we've added the numerators together. They happen to not be like terms, but it worked out okay. All right. Let's look at one that's a little more fun. 8 over x parentheses x plus 2 plus 9 over x, not over, 9 over x, over x. All right. Definitely not the same denominator, but it's close. What do they have in common? X. They have a shared piece. Okay, so when we're finding that least common denominator, anything that they have in common is going to be part of the least common denominator, that x. And then what's not in common? This one has an x plus 2 that the other one doesn't have. So that's got to be part of the common denominator. Does this one have anything else that the other one doesn't have? No. So that's going to be my common denominator. Do I need to do anything to this first fraction? No, it's already got everything. Second fraction needs what? It needs an x plus 2. So I'm going to multiply bottom times x plus 2 and top times x plus 2. And then we're going to do that math. It'd be 9x plus 18, right? And then simplify from there. So we got 8 plus 9x plus 18. So the like terms would be 8 plus 18. Should be 9x plus 26 or x plus 2. Can I factor that numerator? No. Okay, so if it won't factor at all, I know I can't simplify because it doesn't match anything that's in the bottom. I know I'm done with that one. That least common denominator. Got that, the shared piece, and then what's missing. Let's do this one. 7x over x squared plus 3x minus 3 over x plus 3. All right, so this one's a little bit different. What do we notice about the denominator of the first fraction?
It has squared.
It has an x squared in it, and anytime we see kind of a polynomial looking thing in the denominator, we want to think about factoring that. So how does the bottom part factor in first? They have a GCF of an x, so I'm going to pull that out, and that leaves what in parentheses? X plus 3. Oh, wow. Well, that matches that, right? So that's helpful when we go to find the common denominator so I can do the subtraction, right? So I've got a shared piece that's an x plus 3. So my least common denominator, I know it's going to have an x plus 3 in it because both of them have that part in the denominator. What part does one of them have, the other one doesn't? This x. So I need that for my least common denominator as well. Does this fraction have everything? Yeah. It's got the x, it's got the x plus 3. Okay, so, like we're disregarding that part now. This is the denominator for that now. So 7x over x parentheses x plus 3 is going to stay the same. What does the second fraction need? It needs an x. It's got the x plus 3, but it needs an x. So I'm going to put a x times both the top and the bottom. So that's going to be minus 3x over x plus 3. What's 7x minus 3x? 4x. Oh, we got like terms there. That's nice. X plus 3. Oh, can I simplify that? How, Jake? the x. This x and this x can cancel each other out. 4 over x plus 3. Looking for that simplifying that could happen at the last step. Now, they're always looking to simplify if possible. Let's step it up a little bit here. 7 over 9 x squared